So the equations, parametric equations for the line that we found in the preceding are x equals 5, y equals 9, and z equals 6 plus 8t. Now we're asked to find the point where x of t equals 2. Okay, well, x of t equals 5. There's no t term in this thing, so that there's no way we can make x equal 2. X is 5, and that's what it is. So I say that point where x equals 2 ain't possible because x is 5. There's no t factor. Well, I said t factor. It's actually t term. There's no t term in x of t, so it just can't be 2. Okay? And I use the ain't and can't in honor of best friend, probably maybe the best friend I've ever had, who was trying to teach to play golf, and he was a pretty good athlete, probably better than me at most things, and I wasn't great, but I was a pretty good golfer. But I tried to explain something to him, and poor Denny, you just get frustrated and say, I can't do it. I can't do it, and so I think of him when I say that. Okay, anyhow. So, the idea is simply if x of t is 2, there's no way x is going to be 2. Now let's suppose the equations were different. Let's say instead of 5, 9, 6 plus 8t, the equations were 5 plus 7t, 9 minus 5t, and 6 plus 8t. Well, then we'd be able to find a value of t that makes x equal to 2. Okay, so we come down here and we say, well, okay, is there a point where x equals 2? If so, what point? Well, x equals 2, so that 5 plus 2t would equal 2. So we find the value of t that makes 5 plus 2t equal to 2. That's easy to do. X is 2, so 5 plus 7t should equal 2. And we solve that, and we find that t is negative 3/7. Now, if t is negative 3/7 when x equals 2, we can determine what y and z are when x equals 2, just by plugging the negative 3/7 for t into the equation for y of t and the equation for z of t. And we do that. So y is 9 minus 5t, which is 9 minus 5 times negative 3/7, 78/3 if I did my arithmetic correctly. Z equals 6 plus 8t, 6 plus 8 times negative 3/7, 18/7 again if I did my arithmetic correctly, in which case we would say that the point, and if the point 2 78/7, 18/7, it has to lie on the line. Okay, now let's think about what's being said. These are not the equations of the line we looked at previously. These are the equations of a different line. And if t equals 0, x, y, and z are still 5, 9, 6. So it would be a line through the same point, 5, 9, 6. And our schematic diagram might look very much the same, except that our v vector would be different. And we can determine that the v vector has to be different. If we have the origin down here, then the vector from the origin to the point 596 is just the vector 5i plus 9j plus 6k. That's been written down elsewhere more clearly, so you should probably have that in your notes in case you can't read it, but it's actually, I think, maybe fairly legible. The plus sign's a little, I don't know if that made it better or worse. Okay, so here's a point 596. And our line then has to go through that point. So there has to be some vector v, and it could be any vector v, that's in the direction of that line. So if there's any point on that line, v would be the vector from this point. V could be the vector from this point to that point. So there's some vector v. Now, we know that the point corresponding to these coordinates has to lie on the line. That's how we define the line, by these parametric equations. So let's just take this point here. This point is on the line, therefore for some value of t it has coordinates 5 plus 7t, 9 minus 5t, and 6 plus 8t. It looks like I tried to close a parenthesis there. I don't remember doing that, but I'm sure I did. Okay, so but by these equations, any point on the line has this form for some value of t. Now, any point on the line has the form, it corresponds to the terminal point of a vector from the origin to that point. Okay, the vector from the origin to that point has to be 5 plus 7ti, and then 9 minus 5tj, 6 plus 8tk. Okay, so this vector corresponding to this point, well, there's the vector. We know this vector, 5i plus 9j plus 6k, the vector from the origin to the point we know on the line. So what's our vector v? Well, TV, vector from here to here, is just this vector minus this vector. Well, if we subtract this vector from this vector, we get TV, which is 7ti plus minus 5tj plus 8tk. That is, this vector here, when we subtract 5i, we're going to subtract 5i, we're going to be left with 7t. Subtract 9j, we're going to subtract 9j, and we're going to be left with negative 5t times j. And then we're going to subtract 6k, so the 6k will go away. We're left with 8tk. So here's our vector TV. Now, what's our vector v? Well, according to this model, the vector v that corresponds to these three equations is just 7i plus 5j plus 8k. Now, the shortcut is you can read the coordinates of this point from these three coordinates, 5, 9, 6. You can read the components of the v vector because they're multiplied by t. So it's 7, negative 5, and 8. 7, negative 5, and 8. And I wrote plus 5 here. Minus 5. Okay? Now that's a shortcut, but you should understand why that's true. You should understand this entire set of reasoning, this entire set of relationships. Okay? In order to really understand the equation of a line and to be able to answer subtle questions about a line given its equation, or find the equation of a line given various conditions.